Katy Perry. Okay, so we're gonna need to rebuild this right out the jump. What's up?
Can I grab my sweatshirt?
Yeah. Am I annoying?
Nope. I'm just gonna close this door now.
Okay. Build it, build it, build it, build it. Let's look at the storage. How much storage do we have? 30 gigabytes. Oh. What the helly? What the Katy Perry?
So we started using quite a few. The people of LNG were wiped out. It happened in the course of one night. Is that true that Red Hurt Chase did it?
Open JDK platform. Why do you need to use this? Publisher Eclipse. Fine. Why is it opening this Java? Why is grabber.cpp not found in? It's right there. Okay, should we live code it? Ooh. Oh. Why isn't that? I don't understand it. It needs to link, like it's not saved in here for some reason, but it is. Live code. Oh, there we go. There we go. Grabber. There it is. Go, 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 go. Successfully linked. Live coding successful. So if we look at this, this is still. And what if we build this now? Control Shift B. Script Raider development build, please. Succeeded. Love that for me. Oh, because Grabber isn't on here. Blueprint compiler. Okay. 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 Excuse me. What the fluff? Where's my Udemy course? There we go. What the helly? What the Katy Perry? Blueprint callable. Alright, why isn't this working? It's not showing up in my learning, which is weird. Find component class and null pointer. Yes, it would be great to maybe this is a Firefox. Let's go to Edge. Udemy. Bad gateway. Is it my interwebs? No, interwebs are working. Still not showing up in my learning. What's the dealio? Find component by class. We got come on, why isn't this working? Call me up if you's a gangster. Okay, so it's not working. Incognito. How do I go to incognito? Where should it be? Oh, this is still Firefox? Am I gonna need to log in? CPU's running at 40%. That's fine. Spotify, we can close you out. Firefox is taking a lot. Edge, please. Bad gateway. All right, it looks like Udemy is down.
So guys, for the first step, once you're in your web browser, you want to click on the three dots on the top right, and then click on settings. And then you want to click on privacy and security, and then you want to click on delete browsing data. Now these steps are going to be different depending on your web browser, but they'll still be pretty similar. And now you want to click on basic, and you want to make sure that cookies and other site data
That was 6 days ago. Oh no, this is live. Yeah, Udemy's down right now. All right, we can go input action mapping. Let's do this one instead. This is by Druid Mechanics, uploaded 2 years ago. But
hello and welcome. In this video, we're going to talk about Unreal Engine's enhanced input system. Now, I have the enhanced input documentation up, and we're going to be discussing how to take a project and convert it to use enhanced input. Now, before we start doing that, I'd like to read through the documentation which explains the enhanced input system and discuss what everything means here so that we're sure that we understand what it is we're doing as we start using this new system for handling inputs. And we'll compare it to the old system and get a bit of understanding about how the new system is improved and has more capabilities. So, as we're reading through the documentation, I'd like to take a look at a Unreal Engine 5.1 third-person template project. Now, this very much behaves the same way as a third-person template project in an earlier Unreal Engine 5 version. We have the same behaviors, but this project is using the new enhanced input system. If you create a new third-person template project, it'll be set up to use enhanced input by default. Now, you don't have to create a third-person template project to follow along as we're reading the documentation. If you're short on disk space, you can just watch, but if you have the space, you might as well go ahead and create a third-person template project just so we can open the assets and see what we're talking about. And of course, if you'd like to do that, all you need to do is open your Epic Games launcher and launch Unreal Engine 5.1 or whichever version that.
Call me up if you's a gangster. How did we do this last time? Ugh. Collisions, yeah. That's what I want. Okay, if I go to this, can I just open this and no, I want to open it. So raise your glass if you are wrong in all the right ways. Oops. Open the material editor. Two-sided. What is two-sided? Ah. Yes, we're back in.
Hello and welcome. In this lecture, we're going to be adding a new component to our BP player, the physics handle, and we're going to be learning how we can get a pointer to it in our grabber component. We're also going to look at how we can protect ourselves from accidentally crashing the engine. Let's dive in and see how. Now, in order to grab hold of an object, we need to interact with the physics system, and there is actually a component that we can use called the physics handle, which allows us to grab physical objects and tell them where we want to be in the world, but do it in such a way that it acknowledges physical constraints, so it doesn't pass through walls, and it kind of looks like the object is on a spring rather than rigidly following a specific point that we tell it to go to. So we're going to use this physics handle component. We're going to go and add it to our player BP along with the grabber. So let's go to the add button under the components pane and look for physics handle and add it in. And you can see that it's an actor component, not a scene component, because it goes down in the lower section. So it doesn't actually have a physical transform of its own. What we do with the physics handle is we tell it the object to grab, and then we tell it where we want it to put the object that we've grabbed. If you go over to the documentation, you can see this in the functions that are available. If you scroll down to the functions section, you can see that there is a release component and a grab component at location function. There's also a set target location and rotation. This is where it wants to try and put the object, but obviously it will respect any physical constraints in doing so, and it will do it in a smooth way as if it were on a spring. Now, we're not going to use these functions just yet, but we do need to find a way of getting hold of this component in our grabber component. So how do we do that? Well, let's go over to our grabber CPP and have a look in begin play and try and get hold of it. Now, there's a function on any actor which allows us to find a component by its type. But what is the type of the physics handle? Well, it is a U physics handle component. Now, to get hold of this type, we need to use an include, and you can see the include in the documentation is physics engine / physics handle component. So let's copy that, go over to our grabber CPP, and add it in under our draw debug. Helpers. Then what we're going to do is we're going to do a get owner to get hold of our owning actor pointer, then do an arrow and call find component by class. Now, this function is a special kind of function called a template function in C++, and this means that you can pass it some parameters that actually get evaluated when you compile. And the way you do this is using angle brackets like this. So you use an angle bracket after the function, and you give it the type that you want it to find, which in our case is the uPhysicsHandle component, like so. And then you close the angle brackets. But because it's a function, you do need to call it using regular parentheses as well. So then you put the second set of parentheses after this. So you can see that these compile time arguments are passed in using the angle brackets, and then the runtime ones are passed in using the parentheses. Now, like a regular function, this will have a return value. And in this case, the return value is going to be whatever type we've passed in here, but as a pointer. So we can take a uPhysicsHandle component pointer and create a variable for that, which we're going to call the physicsHandle, and set it equal to this getOwnerFindComponent by class. Now let's remember a semicolon at the end of this line, and that is everything required in order for us to get hold of another component on our same actor. Now remember that I told you that pointers can be dangerous because sometimes they can be null, and that can lead to a crash. So imagine we'd forgotten to put a physicsHandle component on our actor, or we've put a grabber on a new actor and we haven't hooked it up with a physicsHandle component yet. If this is the case, then the physicsHandle pointer is going to be a null pointer. And if we try to use the arrow operator or dereferencing operator on that pointer, it will crash our engine. And it can be sometimes really hard to see what that crash looks like. So I'm just going to go ahead and actually...
Johnny boy, I'm doing I'm just following a lecture right now. This is Crypt Raider. Sorry,
cause this crash just to show you, and you might be able to recognize it if it happens to you in the future. I'm going to reassign our physicsHandle pointer equal to the null pointer special keyword. It's all null PTR. That's how you spell null pointer in C++. Then you put a semicolon at the end. And then what we're going to do is we're going to do physicsHandle arrow get name like so. And if we go ahead and compile using live coding, and when that's finished compiling, we're going to go ahead and make sure, first of all, that we save anything that we've got here going on.
Control S. Go back to live compile. Why am I using it? Like, what is the Java that's getting used? Wait, that's output. Johnny boy. Yeah, baby. We're linked.
In our BP player, because I'm about to crash the engine. And if I go ahead and hit play, this is the result that we get.
Come on, you just need to do that for a freaking null pointer exception? Great.
A crash reporter. And you may be tempted to think when you see this that something's gone wrong with Unreal, but it's actually your code that's at fault here. You can see that in this crash report, the first line says that the issue is coming from ugrabber : begin play. And it's actually giving us the line number as well, which is line 28. So you can see that at this point on line 28, when we dereferenced that pointer in order to call a function on it, we actually committed a grave error in not checking first whether that pointer was null. So that's what we need to do. And we do that with an if statement. We basically say if physicsHandle is not equal to null pointer, then we can go ahead and call stuff on that physicsHandle. So we can put the physicsHandle get name inside of this if statement, and that protects us because that code, that dereferencing code, won't be executed in the case where we have a null pointer. So I'm going to go ahead and remove line 27 now, where we are setting it to a null pointer, and I'm going to challenge you to print the component name for yourself.
Okay, so yes, open this. I'm gonna be pissed if I have to go reload everything. Great. Great. Why isn't grabber? Bro, don't crash my shit on purpose next time. Here we go. Success. Add my boy grabber in there. We'll click this in. Delete this. This is grab. And this is release. Control S. And then we're going to go down here. Live compile live code.
So only print if we have the actual component. Basically, we don't have a null pointer. And use an else to warn if we didn't manage to get hold of that component. And try removing the component to check. Pause the video and have a go. Okay, welcome back.
Oh.
So we're going to create a new ulog message here. And we're going to say got physics handle $s. And we've got this physics handle name, which I'm just going to cut and paste as the second argument, or the fourth argument into the ulog. And I'm going to put a star because it is a string. Now let's add an else statement under our if statement. And in here, we're going to put another ulog, which is going to be, this time instead of a display, we're going to put a warning type message. So it's going to come up in yellow. And we're going to say, no physics handle found, exclamation point. Now I haven't got the editor open, so I'm going to do a Control-Shift-B to build within Visual Studio Code, close down the terminal when it's successful, and relaunch from the U project. Once that's launched, let's go ahead and hit play, open up the output log, and we should see the log message got physics handle, which the name is, funnily enough, physics handle.
Why?
Now, what if we were to go over to our BP player and actually delete that physics handle, and go ahead and play now. Have a look at our output log, and there you go. We've got a yellow warning that no physics handle was found. So let's stop play. Let's go ahead and add the physics handle back because we are going to want it, and we'll save the player BP. Great stuff. So we've figured out how we can get hold of other components from within a component, and we've learned how to deal with null pointers and why we need to be careful. I'll see you in the next lecture.
I'll see you in the next lecture.
Hello and welcome. In this lecture, we're going to be learning to draw debug spheres in our scene so that we can visualize different F-vector locations in space. Let's dive in and see how this works. So very soon we're going to want to call our grab component at location with a rotation. For this we're going to need to know a couple of things. Which component we're trying to grab, the location, the rotation, in this case the bone name we can happily ignore, but we do need to know these other things. So when it comes to the rotation, this is pretty straightforward because we can just take the rotation of our component. When it comes to the component, that's also quite straightforward. All we have to do is take the component we collide with when we're doing our sphere trace. Now the location on the other hand is a little bit more tricky because we don't just want to take the location of the actual component, because I might be looking at it here, I might be expecting to grab it by its head, but if you see, the root of this object is actually down near the base. So it can lead to results that are a bit strange. I grab it up near the top, near the wings, and it will then move the gargoyle up and float too high. So it doesn't feel right if you do it that way. I've tried, and it's just a bit odd. So what we're going to do is we want to find where we hit this gargoyle when we do our sphere trace. If we go over to our grabber CPP, there's actually a couple of options in our hit result for getting some vectors of location. So if you do hit result dot and then hit a control space, you can see a bunch of different things in here. You can see that one of them is the component that we've hit. We will be using that later on. There is an impact point. That could potentially be the interesting one. There's also a location. So to figure out whether it's the impact point or the location that I want, ideally, we'd have some way to visualize this in the world, visualize the point that we're trying to see. And fortunately, there is. In the same include file that we found our drawing a debug line, there is a draw debug sphere function as well. And it has a lot of the same parameters. You need the world as the first parameter, the center of the sphere, the radius is a float, the number of segments that the sphere should have. So we'll see what this means when we actually draw it. Then there's a color, and then whether it should persist in the scene and for how long, etc. So let's have a go at drawing this sphere. And initially, I'm just going to use it to draw a sphere at the endpoint of our sweep. So we're going to call draw debug sphere. We don't have to include anything new because we've already got draw debug line in here. Get world's going to be the first argument. Then the center of this sphere, which is going to be the end vector. The radius, I'm going to give it 10 centimeters radius. I'm going to give it 10 segments as well. And then I'm going to have an F color. This time let's give it something different. F color colon colon, maybe a blue sphere this time. Persistent lines, I do want this to be true because we call grab once, not every tick. So I'm going to set this to true. Then the lifetime, I'm going to set the sphere to last for 5 seconds. And then the rest is less important. I'm going to put a semicolon at the end of the line and recompile. If we go ahead and hit play after it's finished compiling, and we'll move back a little bit from the gargoyle. And I'm going to left click, and you can see the sphere appearing 4 meters in front of where I'm looking. Now I thought it would persist for 5 seconds, but actually what I need to put in here is not that persist is true, because that basically ignores the lifetime entirely and just keeps them around forever. So if we put in false and then the time of 5 seconds, so I just made a mistake there, which is easy to do and easy to misinterpret documentation, and then we go ahead and hit play in our game, and if we create one of those spheres, after 5 seconds, it disappears again, so it won't be cluttering our world for too long. So let's challenge you to figure out which location we need from our hit result. Draw a debug sphere for each of them, the hit result.location and the hit result.impact point, and use different F colors to display it and make it clear which one is which. And what's the difference? Which one do we think we might need? Pause the video and have a go. Okay, welcome back. Let's go back into the code and go down into our if statement where we've got a hit marked out. So we will have some sort of hit result. And just before we get hold of the actor, what I'm going to do is draw debug sphere using get world. And the first location we're going to draw is the hit result.location. Going to go for 10 radius, 10 segments, F color, green this time, and persistent lines is going to be false, and the lifetime, let's make it 5 seconds. And then let's copy this line, because we want almost exactly the same thing, except we want to change out hitResult.location for hitResult.impact point. And the color, maybe we'll switch that out to be red, so that we know the difference between the two, green and red. Let's compile and head over into the editor. Let's hit play. And you see that when I don't actually hit anything, I just get this blue sphere. And if I go up to the gargoyle, look at the gargoyle and try and hit it, okay, we've got two very different points.
Whoa, what? Oh no, I'm stuck. F8, kind of control Q. Okay, that was weird. Success. Balls. All right, that works.
Here, the green one is quite far away from the gargoyle, the red one is much closer. So what's going on here? Well, if we look at the hit result documentation and come down and have a look at what location is meant to be, you can see a discussion here that location in world space where the moving shape would end up against the impacted object if there is a hit. And if I eject and pause for a second to see what these points actually look like, you can see that green one does indeed match that description. We have a 1 meter radius sphere that we are projecting or sweeping towards this gargoyle, and it would hit the gargoyle as soon as it gets to this green point here, because that's about a meter radius around it. Whereas the impact point tells us where that sphere hits the gargoyle. Now that is much more likely to be where we want to grab it, because it's actually on the gargoyle. If I grabbed it over here, the gargoyle would rotate and spin around some point randomly in midair and not look like we're grabbing it at all. Whereas around this red point, it looks like I've just grabbed it by the wingtip, and that would look natural. Great stuff. So in this lecture, we have learned a little bit more about what's available from a hit result, and we've learned how to draw some more debug objects in our scene. I'll see you in the next lecture. Hello and welcome. In this lecture, we're going to be setting up our grabber so that we can actually get hold of our gargoyle statue and take it around with us in front of us. Let's dive in and see how we do this. So it's time for us to start calling this grab component at location with rotation. Now, as I said before, there's actually two parts to this. We need to grab the component, and then later we need to set its target location and rotation as well so that it moves around. So first things first, in our grab function, we're going to need to get hold of a pointer to our physics handle. So I'm going to copy the line from begin play, and I'm going to go over into the grabber. I'm going to put it in here, and to protect ourselves from this being null, well, what should happen? Well, actually, there's nothing that we want to do if we don't have a physics handle. We can't grab anything. So we could put the whole body of this grab function into an if statement, but that can look a little bit messy. So what we can do instead is what's known as an early return. Essentially, we just say if the physics handle equals null pointer. You have to put a double equal sign here, otherwise it's an assignment. Then we can go down to do some braces, and we can just put a return in here. So what this is going to do is, if we've got a null pointer for the physics handle, it returns straight away and doesn't execute the rest of the function, thus making it safe in the rest of the function to use the physics handle as we wish. So we're going to do that. We're going to go down into where we have a hit. I think we don't need these log messages anymore, so I'm going to remove the else statement. I'm going to remove basically everything from the body of the if statement, and we're going to use our grabber. So we're going to do the physics handle arrow grab component at location with rotation. Then we have to provide it with a component we're trying to grab. If you have a look, the thing that it's expecting is a uprimitive component. Let's see if we got anything of the sort in our hit result. I'm just going to pop over to the documentation page for it and look for uprimitive component, and you can see that get component would return the uprimitive component that was hit. Perfect, that's just what we need. So we're going to look for the hit result dot get component, and that's going to give us what we want for the first argument. Now, next is an F name for a bone. Now, we don't actually want to grab anything by a particular bone. This would be the case if we had a skeletal mesh, but we don't. We have a static mesh. So we just use name underscore none. And generally speaking, with F names, where it's talking about bones, this comes up quite a lot. If you don't want to put anything in, you use name underscore none. Now we need the location that we're going to grab it at, and we've already said that we've looked into this. It's the hit result dot impact point. And then the rotation, well, the current rotation of that component will do, or the current rotation of the actor, whichever you prefer. So the hit result get component, we're going to grab that, hit result dot get component dot arrow, because it's a pointer, get component rotation, like so. Now we can put the closing parenthesis on a separate line, and I'll put semicolon there to finish off the statement, and that should be effective at grabbing our components. Now the next part of the puzzle is in tick
Shibloinks.
grabbing our components. Now the next part of the puzzle is in tick component, where we want to again use the physics handle. So I'm going to copy the code for now, knowing that copying code to 3 places is a bit too many, and we might want to think about pulling it out into a function so that we reuse that. But in tick component, we're going to use the physics handle. We're going to early return if we can't get hold of a physics handle. And then what we're going to do is we're going to try and set that target location. So we're going to do physics handle arrow set target location and rotation. And let's have a little bit of a think about this. What kind of target location might we be interested in setting? Well, essentially, it's going to be the same as we did with the endpoint. We're going to take our current location, then move it outwards in the forward direction by a certain distance. Now this will be configurable. You could use the max grab distance, but I find that in practice that feels too far away. So if we go to our grabber.h, we're going to create a new uproperty called edit anywhere, and it's going to be a float called the hold distance. And I'm going to set this to 200, so it's going to be much closer to the player. Now, if we go into the grabber CPP, we can go into our tick function, try and create this target location. So it's going to be an F vector called target location. I'm going to set that equal to the get component location plus the get forward vector multiplied by the hold distance. So then we can use that as
I think I'd call this grab distance, not hold distance. Physics handles,
the target location. That's going to be our first argument. And then we need the target rotation. Well, for that, I'm just going to use the rotation of the current component so that as we look around, we're going to rotate the object with our view. So we can just do the get component rotation to get the rotation of the current grabber scene component. Now let's put a semicolon on the end of that line and recompile.
live code it. Yeah. And it goes a little
And see how this works.
like
now, after we've compiled successfully, let's select the gargoyle and just make sure that we change its mobility from static to movable. Because we do need it to be able to move in response to physics. And let's make sure that it's simulating physics. Let's go to the physics category and check the simulate physics button. Let's hit play and try. And pick it up. So nothing's happening at the moment, but it does seem to be stuck inside the floor. So that's not ideal. Let's try and lift it up a little bit so that it's not stuck inside the floor. Let it drop onto the floor like that. And now try and pick it up. It does seem to have got stuck inside the floor again. So let's just try a second time. Okay, so it's a little bit unreliable. And sometimes if you catch it straight away, it picks up the gargoyle just fine. And you can pick it up like that. I'm noticing the rotation isn't correct. And this is because I've used the wrong thing in the grabbing the physics component. I got the rotation of the gargoyle, and now we're trying to keep that rotation. What I actually needed to use was the rotation that we're using in tick, the rotation of the grabber. So let's go ahead and change that and recompile. And we'll just hit play again and try and grab it.
Access none, trying to read real property grabber. Execute.
rotation that we're using in tick, the rotation of the grabber. Thing in the grabbing the physics component, I got the rotation of the gargoyle, and now we're trying to keep that rotation. What I actually needed to use was the rotation that we're using in tick. The rotation of the grabber. So let's go ahead and change that and recompile, and we'll just hit play again and try and grab it. There you go. This time I grabbed it and I got the correct rotation, the exact rotation that it had. And you can see that it does look like it's being grabbed on a spring. If I try and push it through a wall, it tries not to go through the wall as much as it can. It does eventually pop through the wall, but it is trying to observe physics as I move it around. So let's challenge you now to pull out a new function called getPhysicsHandle. It's going to be private. It should return a uPhysicsHandle component, and it should remove this duplicated code of needing to get the owner and find the component by class. You can also make it potentially const, see if you can, and make it log if we don't have a physics handle component, give a warning log so that it shows up and we know that we've done something wrong. Pause the video and have a go. Okay, welcome back. First of all, we go to the header file where we're going to put this in the private.
Is that live compile? It's going. All right.
Section, but underneath the U properties, I'm going to have it return a U physics handle component and put an asterisk here. Now, because we are using this type here in the header, we need to actually take our include and cut it out of the grabber. So the include regarding the physics handle, we need to put it in the grabber.h.
Grabber.h.
Where we're going to put it above the generated.h. That's the last thing always in our header files. And why do we not need to have it in the CPP as well? Out of, we need an asterisk here. Now, because we are using this type here in the header, we need to actually take our include and cut it out of the grabber, so the include regarding the physics handle. We need to put it in the grabber.h, where we're going to put it above the generated.h. That's the last thing always in our header files. And why do we not need to have it in the CPP as well? Well, because we're including grabber.h, so anything that we put in grabber.h will automatically be in the CPP. So we can put that include in there. Now we can go down to where we're defining this function and call it the getPhysicsHandle, pair of parentheses like that. And I think this should be const. It shouldn't change anything in our grabber to call this function. Just go over to the CPP and go to the bottom where I'm going to paste in our definition. I'm going to stick a uGrabber : at the front, and then I'm removing the semicolon, adding a pair of braces. And what we want to do is take where we've got this getOwner line, and we're just going to cut that out and replace it with getPhysicsHandle, like so. And then in the getPhysicsHandle, we can simply return the getOwner, find component by class, etc. And now we can replace this also, where we're doing it in tick component, we're getting hold of the physics handle. Let's replace that little bit of code with getPhysics. Handle. Now, it's such a small piece of code, it's almost not worth it, but it's definitely worth it for the the practice at this point, and for the fact that we might add some log messages. Now in begin play, we don't actually need to get the physics to handle at all, so I'm just going to remove that code there. But what I am going to do is I'm going to add a log message. So we're going to create a variable to store our result here, because if we return and then try to print a log message, that's not going to work. So we're going to have a uphysics handle component called result. That's what we're going to return out of here. And we'll say if the result is equal to null pointer, well, then we need to ulog with a warning, or in fact an error really, and we're going to say grabber requires a uphysics handle component. And then after the if statement, so this will happen whether or not it is null, we're going to return the result. So let's go ahead and compile that and check it all works. Seems to have succeeded, and I can see it must be working.
I beg your pardon. That's crazy. Things resin. That's nasty. I don't even know.
Alright, did this fix anything? No. Just Google this. Can I copy and paste this actually?
Working because when I left click in the scene, I'm getting the blue or debug orbs being drawn, and they wouldn't be drawn if we weren't getting hold of that physics handle component. Great stuff. So in this lecture, we've been able to
Okay, clearly there's something wrong with my code. I probably just need to rebuild this. TBH. see. Let's just do that real quick. Succeeded. Now let's open her up quite quickly. Blah, 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 blah. So nice. All right, I did it. Time to Minecraft. Time to craft some mines.